going to evaluate how effective our prototypes were yesterday and talk about possible changes we can make to them. I'm Tyler Harlington. I'm a 7th and 8th grade science teacher at the Garfield Middle School in Revere, Massachusetts. You and your teammates will identify one variable that you're going to change and ultimately redesign today, and then we're going to retest. This unit is really based on technology and engineering and physical science principles. The goal of the lab was to maximize thermal energy. What we ultimately wanted to create was a hot water heater. The students had an opportunity to evaluate several different designs, which I created as the teacher, so they can reflect upon my models, their own ideas as they went forward in constructing their own.
Yesterday, we actually built our prototypes, and before that, we learned what convection, radiation, conduction is.
The testing process was pretty structured.
59, set time.
And really reflected the effectiveness of their design.
21.8.
Yeah, 21.8.
They knew today that they were coming in to redesign their prototype, and they were going to have an opportunity to make changes based on the evidence that they gathered yesterday. Discuss with your teammates during yesterday's testing. Were you able to recognize any thermal energy principles within your prototype? If so, where were they present? I really wanted them to think about thermal energy principles that were on display as they tested yesterday.
The radiation from the
lamp?
The lamp going into the water, and then the convection was actually when the thermal energy
because you know how the thermal energy reflected off of the aluminum and into the tube?
It was radiating off of the aluminum into the tube so the water could get heated.
And then the conduction occurred where the
hot water was hitting the tube.
And the tube was touching aluminum.
Yeah.
They discussed with each other, and then we shared out as a class all the different principles that we noticed in our prototypes.
We thought about when the water gets into the cup, to not let the heat out, we use the cotton balls as insulation, and we use these so it would reflect the energy back into the water and make the water warmer.
We discussed how the thermal energy was radiating off of the tinfoil over here, and it was radiating onto the water so that it would become heated.
Why did you pick a certain color that relates to our thermal energy principles?
We use black tape and black insulators because the color black keeps the heat in and it attracts heat.
So it absorbs the heat energy. Good job. So we're thinking about absorption, reflection, and those different components to thermal energy. The ultimate goal was to identify a variable which we would want to change in the end to make our prototype as effective as it could possibly be. I want you to identify or make a claim by writing it on that sticky note, one thing that you would change about your prototype to make it most effective. They documented it on a sticky note, and they physically stuck that to their blueprint, addressing the area of need. Then they had a group discussion.
You guys just want to change the way the tube was placed and just coil it even more? Or travel this tube all the way down there from over here? Make sure the tubing is short this time.
Lower the height on this, and then add a hole, and then add another coil in it, like a loop, so the water can stay in there more and that can heat up. The flow of the water was going very fast, and we wanted to make it just to slow down a little bit so it can stay inside the aluminum more, so it can absorb more heat.
What are you thinking about?
We're thinking about putting more black onto the tube or insulating the tube.
So more black along the tube as an insulator? So as they were describing how they would change their prototype, why are you going to choose black? I'd ask for a reason. Why are you doing this? What's your reasoning behind that? So you're thinking about maybe having black underneath it?
No, black at the top.
Black at the top.
Because it's hitting the tinfoil and it bounces back up.
Oh, okay, so you think light might reflect off that tinfoil back up?
Yeah, it was letting off heat yesterday because I was sweating. You can feel the heat.
Just want to do a quick share out, the major change that you're going to make to your prototype, and then we're going to start the redesign process. Olivia.
The issue from yesterday was that the project wasn't absorbing enough thermal energy, so we decided to go and add cotton balls, electrical tape, and paper.
So you're thinking about the principal kind of absorption. Madeline,
We're gonna add more aluminum foil around the cup and inside the cup.
what's that going to do? What's your reasoning?
When the heat from the lamp reflects on it, it'll like kind of like reflect on the water and it'll heat it up.
Oh, so you're thinking like a mirror? Again, I want you to focus on just one variable that you're changing today. And you can kind of see how that one variable is going to change the effectiveness of your prototype. Let's start the redesign.
Somebody pass me the electric tape. We get more direct heat.
Make it like something pointy at first.
The retesting occurred after the students changed their one variable, and they had an opportunity to go up to one of our 3 testing stations, and I asked them to keep it consistent with yesterday's tests. They set up their prototype underneath our heat lamp, measured to make sure it was accurate. They got a beginning temperature,
20.7 degrees Celsius.
set up a timer,
Start.
and they were able to generate the flow of water through their heaters.
We were checking the temperature every 3 minutes to see the rise in temperature from the beginning to end. 21.2, Shane.
Shane, did we experience a temperature rise?
Yeah. 0.5.
That seems like a more rapid increase today.
It really does. I think it works. 21.5, Shane. Insulator, yeah. 22, Shane. Just 22? Yeah, it lowered. Maybe our final reading. So I'll let you read it off. Check it out.
22.2.
Yeah, accurate reading. Today's results vary. I saw some groups experience an immediate temperature rise based on their variable change. A lot of kids actually experienced a temperature decrease today.
Yesterday it was 1.6 and today it was 1.5 degrees Celsius.
They thought that might have been a failure on their part, but I really wanted to emphasize that it was not a failure because they were able to learn from that experience.
I think it got lower because we added more insulation to the tube so the radiation from the light couldn't pass into the tube. So I think we stopped the flow of light radiation into it.
Please transfer the data into your science notebook, and you're going to start doing some analysis and answering those reflection questions. They're going to reflect upon whether or not that variable made their prototype more effective.
I think the insulator wasn't such a good idea.
This unit focuses on modeling and prototyping, engineer design process, and it also brings in technology and engineering with technical writing skills. We want them to emulate what scientists do in the field. They really had to document, with the use of evidence and thermal principles, their reasoning to support everything that they did when they built their prototype. So they're really interacting as a real scientist, or in this case, a real engineer.